So hey guys, in this video I'm going to explain the cross product of two vectors. So if you find it helpful, please hit the like button and subscribe. The cross product of two vectors a and b is written like this: a cross b. And the cross product of two vectors is a vector itself and its magnitude, so the magnitude of a cross product of two vectors, it's equal to the product of their magnitudes times the sine of the angle theta in between them, and this would be the angle theta in this example. So how do we get the cross product of the vector of the two vectors? Well, there's a more or less simple way to write it down, and we write it down as a determinant. We say the direction x, the direction y, and direction c. Also, you may find it very common a, j, and k. I just write x, y, and c because it's simpler to me. X, y, c, and if we have the a cross b, we will write the x component of the first vector, the y component of the first vector, and the c component of the first vector. Now we do the same for the second vector, the bx, by, and bc. Now we calculate this determinant. Maybe you don't remember, I'm gonna make a quick example. So in the x direction, you just cross these two and you'll have this little matrix. And here you just make, in this direction is positive and in this direction is negative. So you make the following multiplication. You will make the ay times ac, so this is a positive, minus the negative by times ac. Okay, so I'm gonna write this down. This mini matrix is all for the first component, so we product it in the x direction. Okay, so this will be the x component of our new vector. Okay, let's say a times b is equal to a new vector c. So this will be the new x component of our vector c. Now we do exactly the same for the other two components. So now we do it for the second term, the y term. And this time we cross this out and we will have this mini matrix. Let's call it like that. This will be the first two terms and this will be the last two terms. And it doesn't include this. There's also an important thing. When you're calculating the vector of y, you have to put a minus sign on it. This will be minus, and we do the exact same thing with the multiplication of these components. We say the a sub x times b sub c. So this times this, ax bc, minus the other way around, bx times ac, so minus this direction, so bx times ac, and all this goes in the y direction. Now we do exactly the same thing for c. We just cross these two out and we'll see that the miniature matrix will be this one. We make this times this minus this times this. Okay, so positive in this direction, negative in this direction. Ax by minus bx ay, and this will go in the c direction. This will be how you compute the cross product. I'm gonna explain it using a real physical example, and it is torque. Torque is given by the radius at which a force is applied cross the force that is being applied. So r cross f. Let's say we have a radius in our space given the next way. We have that our position where the force is being applied to, it's equal to 5 in x, 10 in y, and 0 in c. This means it's on the plane, on the horizontal plane. If you want to visualize it, it's a direction, a magnitude here of 5, and a magnitude here of 10. On the y component, it will be 10. Let's say we have a force, and the force will be given by minus 10 in x, minus 10 in y, and 0 in z. This will mean the force will also go in the same horizontal plane, and it will be something like this direction. So this will be F. And the other, well, I didn't wrote it, but this is R. So we calculate R cross F. To calculate it, we write down the same matrix we did before. I would say the X component, Y component, and Z component. We write the R, that is the first vector. Note that the order is very important. Also, and it's just important in a sign actually, because this will be equal to minus F cross R. But this is just for you to know. And to take into account when writing the matrix, it's very important that in the second row and in the third row, the order of the vectors actually matter. So 5, 10 in the Y, and 0 in Z. Minus 10 in X, minus 10 in Y, and 0 in Z. We do the same thing again. We blank out these two rows and the column, and we say 10 times 0 minus 10 times 0. As because of the both of them are multiplied by 0, the net result, let's say this is equal to the torque. So the torque would be equal to 0 in the X component plus, well, this is a minus actually, minus, and we cross out these terms and we say 5 times 0 minus 10 times 0. And because both are multiplied by 0, this is actually a 0 as well. 0 in Y. And plus the final term, we blank out these terms and we say 5 times minus 10. So we say 5 times minus 10 minus, because in the negative direction, and we say minus 10 times 10. So it will be minus 10 times 10. And this will go in the Z direction. Here, minus 50, minus is plus 100, so 100 minus 50. So we will have that the torque equals 50 in the Z direction. Okay? So if we write it here, we have that the torque is coming along the Z-axis, and it has a positive magnitude. Maybe you can double check the direction you get actually your result. And it's called the right-hand rule. The right-hand rule goes this way. You go from the first vector to the second vector, and then it gives you an answer. There's a few ways people use it. The first way will be with this sign. So the first vector is the thumb finger, the second vector is the index finger, and the resultant is the middle finger. Okay? So in this example, the first vector is R. Okay? So R will be the first vector, F will be the second vector going along the index, and the resultant vector will go straight up, because we know that both components, they are given on the plane in this example. Okay, so we get the first vector, the second vector, and the resultant. There's a few other ways people use this rule, that is with the same trick, just with an open hand. The first vector will be your thumb, your second vector will be the direction your fingers point at, and the resultant will be the direction your palm is facing at. So we can do it the same. The first vector is R, the second vector F, and it's in the plane, so the resultant will be in the Z direction. And the last form I've heard of is the first direction, you point it with your fingers, and then you roll your fingers to the second vector, and the resultant will be your thumb. So in this example, we say the R vector, the F vector goes that way, so we roll them, and the direction will be on the thumb. Okay, this product is actually very important to problems relating to electromagnetic forces, so just keep that in mind. Thank you guys for watching, and consider hitting the like button and subscribing. Thank you very much. Bye.